For section P4, we're talking about polynomial functions. This should be a pretty straightforward section. The objectives that we're going to be talking about is just making sure you understand the vocabulary of polynomials, whether we're talking about monomials, binomials, trinomials, or just polynomials. Adding and subtracting, where we can only add and subtract like terms. All the different types of ways that we multiply polynomials, whether it's binomials being multiplied, a binomial times a trinomial, all the ways that we use the distributive property. And of course, whenever we use FOIL, that's the normal way most people know how to multiply binomials. But remember, it's just an application of the distributive property. And then we'll look at some special products in polynomial multiplication that just arise so commonly, you really should get used to using them. And then perform operations with polynomials in several variables. So it's not always just in terms of simply x or in simply y. It could be in terms of x, y, and maybe even z. You could have multiple variables within your polynomial. Now, a polynomial in terms of x is where we have x raised to whole number exponents. You'll see here where I say n is some non-negative integer. So it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all in all. So since I say non-negative integer, you might as well just say n is a whole number. And notice I have leading coefficient in this case would be the a sub n because it's in front of the x to the nth term. That leading coefficient ends up being very important as to the graph of any polynomial degree n. Now notice I said polynomial degree n. The degree of a polynomial is just simply its highest powered exponent. So this polynomial that I have up here would be a polynomial degree n. And then of course it could have several lower powers of x in there. Now with polynomials, the standard form is to write the x's in descending power. So you'll notice this is in standard form because it's a times x to the nth power, and then every other coefficient, I'm calling a sub n minus 1 and a sub n minus 2, are coefficients of lower powers of x, all the way down to the constant term, a sub 0 being the constant. Now, if there's only one term in your polynomial, it's a monomial. If there's two terms, binomial, three terms, trinomial. If there's anything more than three terms, we don't call it a quadrinomial or anything like that. Anything more than three, you just simply call it a polynomial. Now, adding and subtracting polynomials. This is the easy thing. But what you have to remember, anytime you're adding and subtracting, you can only add like terms. Like terms are defined to be terms that have the exact same variable factors to the same power. Now, notice in this case, if I ask you to add these two polynomials, I have negative 17x cubed plus 4x squared minus 11x minus 5, and I'm adding that to 16x cubed minus 3x squared plus 3x minus 15. Okay, so I gather the like terms. The negative 17x cubed plus 16x cubed. Now you do not have to show that out. You could have just said negative 17 plus 16 is going to be a negative 1x cubed. I then showed, which you don't have to show, but I showed where I collected the x squared terms. You'll have a 4x squared plus a negative 3x squared, or just minus 3x squared. 4 minus 3 is 1. We'll have a total of 1x squared. Then we gathered together the x terms. You'll have negative 11x plus 3x. That's going to combine to give me negative 8x. And then finally, your constants, the terms without an x, you'll have negative 5 minus 15, and we know those would sum, or in this case, subtract to give me minus 20. Final answer of negative x cubed plus x squared minus 8x minus 20. Once you've combined the like terms, there's nothing else you can do other than to make sure, of course, that your final answer is in standard form, meaning descending order in terms of x. Now, when you're multiplying polynomials, we can say that you can take each monomial term of the polynomial and distribute it to every other term throughout the polynomial. To multiply two polynomials when neither is a monomial, we multiply each term of one polynomial by each term of the other polynomial. Then we combine like terms. So let's look at an example of this. In this problem, I have a binomial times a trinomial. All I've done here is I've used the distributive property. The distributive property says that every term of the first group must multiply every term of the second group. So notice I showed that by just saying, well, if I'm going to take 5x minus 2 times 3x squared minus 5x plus 4, I need to show 5x multiplies every term in the second group. And I also need to show minus 2 multiplies every term in the second group. So I just carry out that multiplication. I get 15x to the third minus 25x squared plus 20x when I distribute the 5x. When I distribute the minus 2, I'll get a minus 6x to the second plus 10x, and then negative 2 times 4 minus 8. At that point, it's just collecting your like terms. You only have the one x cubed, so I have 15x cubed. We have 2x squared terms. Minus 25 minus 6 gives me minus 31x squared. Then I'll have plus 30x and minus 8. Now, the technique that so many students like to use, and I'll go ahead and mention it here, is the foiling technique. FOIL is just a technique to help you remember to use the distributive property, exactly what we just did on the last problem. So FOIL is a gimmick technique, but a lot of students like it, and that's okay with me as long as it helps you do the problems correctly. Whenever you have a binomial times a binomial, the first thing you need to do is multiply the first two terms in each binomial. Then you'll multiply the outer or the outside terms in each binomial. Then you'll multiply the inside terms, be the second term in the first binomial, the first term in the second. And then you'll multiply the last terms in each one. And then you'll combine any common terms or like terms at that point. Now, notice, if I took 7x minus 5 times 4x minus 3. Well, the foiling method would say multiply the first terms, then the outer terms, that's what this right here is, then the inner terms, the negative 5 and the 4x, and then the last terms, the negative 5 and the negative 3. You multiply all those together, sum those together, you know you can combine the two middle terms. That's going to combine to be minus 41x. But now, what I would almost rather you do is just please remember, it's nothing more than the distributive property. 7x distributes to each term in the second group, giving you plus 28x to the second minus 21x. Then you're distributing the negative 5 through each term in the second group, minus 20x plus 15. Again, we combine the two middle terms, you got your minus 41x. So the FOIL technique certainly works, but it's unnecessary if you understand the distributive property. Now, talking about some things that really do help out, these special product formulas. So there are special products that occur so frequently, it's just better off to go ahead and memorize them because, again, you're going to be sitting there thinking about how does this factor or how does this combine if you just don't have it memorized. Now, probably one that you already do know just because it's used so predominantly is the difference of squares. Now, typically we see it in the form whenever we're factoring. A squared minus b squared is a plus b times a minus b. Well, we're trying to go in the reverse direction in this section. We're multiplying out. So I'm just wanting you to remember, anytime you multiply a binomial expression that's multiplied by itself, except the sign in the middle changes, then you can just say, well, it's just the square of the first term minus the square of the second term. And you could see that if you use the distributive property, you get a times a, then you'd have minus ab, but then the next term would be plus ab. So those middle terms cancel, and then you just have minus b times b minus b squared. So anytime you're multiplying a binomial by its conjugate. Remember, the definition of a conjugate is the same two terms with the opposite sign in between. So anytime you're multiplying by its conjugate, it's just going to be the square of the first term minus the square of the second term. Now, One of my pet peeves as an instructor is students who think that these next two are easier than what they are. I see so many students, unfortunately, make the foolish mistake of saying, hey, a plus b quantity squared, isn't that a squared plus b squared? It's never simply a squared plus b squared. Any binomial expression raised to the second power is always a trinomial. Now, if you wanted to write out a plus b times a plus b and use the distributive property, you're welcome to do that. But what's going to happen when you do that, you'd have a times a is a squared, then you would have a times b for plus ab, but then you'd have b times a for plus another ab. It always works out that you're going to have plus 2ab for the sum of those two middle terms. And then, of course, the last term times the last term will give you your plus b squared. So it's a lot more efficient if you'll just remember, anytime I have a binomial that's being squared, then it's just going to be the square of the first term plus 2 times the first term times the second term plus the second term squared. Now, the idea carries over if you have a minus b. It's just that that middle term, you would have a times a negative b times an a. So instead of plus 2ab in the middle, you have a minus 2ab in the middle. Now, please keep in mind the last term is still plus b squared because it would be a negative b times a negative b for a positive b squared. So anytime you have a binomial squared, you should easily be able to remember these two formulas, a squared plus 2ab plus b squared if it's a plus b squared, and a minus b squared is a squared minus 2ab plus b squared. Now, using that in this problem, if I say I want to multiply these two conjugate expressions, now this is the difference of squares, where we can say, well, 7x plus 8 times 7x minus 8. Anytime you're multiplying a conjugate, you can just say, well, all I'm going to have to do is square the first term and then minus square the second term. Well, the first term is going to be 7x. 7x squared is 49x to the second. The second term, 8 squared, is going to be 64. So you can say, well, 7x plus 8 times 7x minus 8, it's simply the square of the first term minus the square of the second term, and I get my 49x squared minus 64. Now again, if you FOILed that out, you would see that you'd get a minus 56x plus 56x, and you just cancel those out, and you get to the same answer with the first term squared and the last term squared. Now, polynomials in terms of several variables. So if I have a polynomial in terms of two variables, well, notably, we'll usually see x's and y's in ours since we're graphing on the xy coordinate plane. So a polynomial is still valid as long as those variables that it has in it are raised to whole number exponents. So n and m in this case would have to be numbers from 0 to, well, infinity, whole numbers, if that's the case. The constant a is still the coefficient, whatever's in front of the listing of variables. The exponents m and m, like I said, must be whole numbers. You can't have any fractional exponents, and it got to be considered a polynomial expression. Now, the degree of the polynomial changes. Before, whenever we have a polynomial in just terms of x, we simply said the degree of the polynomial is the highest powered x term. It's whatever the highest powered exponent is. Now it's slightly trickier. The degree is just the sum of the exponents. So even though you can't multiply x times the y, in order to determine the degree of that term, you'll still say n plus m to determine the degree of each individual monomial term of a polynomial. The degree of a polynomial in two variables is the highest degree of all of its terms. So now if I'm asking you to subtract a polynomial in terms of two variables, it's the same rule that applies. You can only add and subtract like terms. So when I'm giving you this problem here, and I'm asking you to subtract, now I showed an intermediate step and said, if you're subtracting a polynomial, then you can add the negative, and I changed the sign on all the terms in there. This step is unnecessary, but if it helps you, please do so. Really, I would have just went to the very first part and said, well, I have an x cubed in the first one. Do I have an x cubed in the second one? Yeah, x cubed minus x cubed cancels out. Then I would have said I have a negative 4x to the second y. Do I have a x to the second y in the second one? Absolutely. Negative 4x to the second y minus a negative 6x to the second y. That's going to be plus 6. Negative 4 plus 6 is going to give me 2. I'll have 2x to the second y. Keep in mind, the exponents do not change power when you're just adding and subtracting. The only thing you do is combine coefficients. Now I have a 5xy to the second. There is no like term with that, so it just gets brought down. And then I have a minus y cubed, and I could see a lot of people messing up here. It's a minus y cubed, but then I'm subtracting a positive y cubed. Well, negative y cubed minus another y cubed is going to be minus 2y cubed. And you would get to your final polynomial answer of 2x squared y plus 5xy squared minus 2y cubed. Now, typically the order that we want on those is still descending power with respect to x. X is still your independent variable, so usually we'll order those from high to low power of x. Now, if you were asking yourself what the degree of each term of this polynomial, they're all degree 3, 2 plus 1, 1 plus 2, and this one has degree 3. So each term is degree 3, so there's really no greater, higher powered term than the other. But with respect to x, this is written in descending order, which is a good thing. Now, if you have multiplication problems in terms of two variables, you can still use your foiling technique and say multiply the first, the outer, the inner, and the last. And you can see how I've done that here. I would almost prefer just to come down here and say all of this, it's just the distributive property. Distribute 7x times both of the terms in the second group. You'll have 7x times 3x for 21x to the second. You'll have 7x times a negative y for a minus 7xy. That forms my second term. You'll have a negative 6y distributed through both terms in the second group. That's going to be negative 6y times a positive 3x minus 18xy. And whenever you're putting the variables, and there's two of them like that, please don't write that as yx. That would be sloppy. We always put variables whenever there's more than one, we put them in alphabetical order. So since x comes before y in the alphabet, the x should come before the y in these terms. Negative 6y times a negative y, that's going to be a plus 6y to the second. Now we can see our middle two terms can and should be combined. Minus 7xy minus 18xy combined to give me minus 25xy. I just leave my first and last term alone and write it in gorgeous descending order with respect to x. 21x to the second minus 25xy plus 6y to the second. All right, guys, that's the end for this section. Please do try these problems with polynomial operations, addition, subtraction, multiplication, and division. Again, if you run into any problems, please first look at those that I've done from my problems out of the book and the homework assignment. They should mirror the My Math Lab assignment gorgeously. I had a lot of fun working the problems, but at any time I'd be glad to work any problems with you. I want to make sure you're comfortable with any problems in this section.